which option would you choose? Would you choose option one, where you flick one coin and you have to get you have to get one head, okay? Option two, where you spin this, you spin two of these spinners and you have to get the same color. Remember, purple and purple is a good outcome. Don't forget about the white as well, white and a white. So that would be a good outcome. Okay, so which option would be easier to do, option one or option two? So press pause and think about it. Okay, so here, well, option one you can do in your sleep. So probability of getting one head would be 0.5. Option two. Now, in the past, in the past we've done something like a die where everything. So you've got 6 options: 1, 2, 3, getting 1, 2, 3, 4, 5, and a 6, and they're all equal likely. So drawing using the table diagram would be easy, but here the probability of getting a purple is not the same as the probability of getting a white one. It is possible to do it is possible to use the table route. So just drawing a table, you could draw it, but I don't really want you to I want you to use an alternative method rather than the table. But by the way, let me just glance over the table method. So you could do it like this: 1, 2, 3, 4. So this could be so looking at this one here, yeah, this could be a purple, and looking at this here, this could be a purple. This here would be a white. This here would be a purple, and this here would be a white. And going across here, this here would be a purple. This here would be a white, and this here would be a purple. Okay, and then this would be a good outcome, not a good outcome, not a good outcome, and so on. You could use the table route, but I want you to use another route, because later on the table method breaks down when you have something like 3 spinners. So suppose you have another spinner, I don't know, this one here. But the table spinner only works when you have one event here, okay, and then you got another one here. So what happens when there's another spinner? The table method breaks down. So let's use another method. It's called a tree diagram. So starting with this spinner here, let's draw a map of all the things that could happen here. You could just get a purple one, okay, or a white one. So pretend you spinning this once, okay. You are trying to spin this one here. You could get a purple or a white one. That's the only thing that could happen, either purple or white. Okay, so here you start here, so you could get a purple or a white. Okay, so you spinning this first spinner here, you could get a purple or a white. Now the probability of getting a purple would be 3 over 5. Okay, the probability of you getting a white would be 2 over 5. Okay, so let's say you starting here, you could get a purple one or a white one. Let's assume that you get a purple one. Okay, so you've gone down this route. You've just spun it and you got a purple one. Now jump to this spinner here. So with this spinner here, you could get a purple or a white one again. Okay, so this could be a purple and this could be a white. So here the probability of you getting a purple would be 2 over 3. So we are talking about this spinner at the moment. So the probability of you getting a purple one would be 2 over 3. Okay. Now so you've started here. You just spun this one here. So you've got, and you happen to get a purple one. Now you spin this one. So you're here. Now let's say you get a white one. A white one would be 1 over 3. 1 over 3, because look, this is the only well, this is 1 over 3. Okay. Now let's go back to the beginning again. So you are here now. You spin this one here, this big spinner here. The probability of you getting white would be a 2 out of 5. Okay, so let's assume you get a white one. Now you come to spin this triangular spinner here. So you could get a purple one, or you could get a white one. Okay, so getting a purple one would be 2 over 3, and then the probability of you getting a white one on this spinner here, on the triangular spinner, it would be 1 over 3. So in effect, what you've got is a map of all the possible events. So you so this is really a map of all the things that could happen. Now you getting the same color would be purple and purple. So this is a good outcome. Okay, purple, you getting a purple on a big spinner and you getting white on the triangular spinner, this one is no good. A white and a purple, this is no good. A white and a white, this is good. Okay, bear with me, because I know this method is a lot more complicated than the table one, but the table one breaks down when things get complicated, whereas this method is much better. So just trust me for the time being. Just use this method. So the probability of you getting a purple and a purple, okay, so that would be a good outcome here, and a white and a white, so that would be a good outcome. Now the thing about this this tree diagram is that you have to pretend you starting here. If you spin this, you have to, let's say you get a purple, and you have to get a purple over here. Every time there's an and, okay, every time there's an and, because you have to get a purple one here and a purple one over here, you have to times. Okay, so here I have to get a purple one and a purple one here. So basically you walking down this branch here would be, so the probability of purple and purple equals 3 over 5. Okay, now because we're talking about purple and purple, we have to times. So times 2, so times this thing here, 2 over 3, 2 over 3. Okay, and that equals well, top times top, which is 6, and then bottom times bottom, that would be 15. So the probability of you getting a purple and a purple would be this. Okay, now let's look at the white and the white. So the probability of you getting a white and a white would be well, you've got to go down this route and this route here. So you are following this whole branch here. So you have to get a white and a white. So get this, because you're following the whole branch. It's an and this, so you have to times. Okay, so probability of you getting a white with a big spinner, 2 over 5, and this thing here, so 1 over 3. Okay, so that equals now top times top, which is 2, and then bottom times bottom would be 15. Okay, so here's the thing: you've gone down this route here, this and this, but then remember, this is a map of all the things that could happen. You could, this thing here, this route here is one route that could happen, or you could go this one here. The thing is, when there's an or, you add. So I know this seems complicated, but just trust me in this. You could get this or this route down here. Okay. Now when there's an or, you have to get this branch here, add it to this branch here. So you could go, the probability of you heading down this route is given by this thing here. The probability of you going down this route here is given by this thing here. This thing here. So when we're talking about this route or this route here, you have to get this, add this. Okay. So probability of same color, that is, equals probability of purple and purple plus probability of white and white. Okay, now, so that equals, well, probability of purple and a purple is given by this thing here. So that would be 6 over 15, and the probability of white and a white is given by this thing here. So plus 2 over 15. Okay, and oh yeah, now it's just adding the two together. This add this. The two denominators are the same, so that's quite easy. So just merge the top two parts. So it will be 8 over 15. Okay. Now jump over to a calculator. Hang on, where's the calculator? So 8 divided by 15 equals 0.53 equals 0.53. So flicking a coin is 0.5. Getting the same color is 0.53. So actually, this is slightly easier to do than flicking a coin and getting one head. Okay. So hang on, let me clear up everything. So the probability of getting this, it would be this. Probability of getting a head, one head, would be 0.5. Okay. So this option's better. So yes, you could use the table diagram, but for the time being, learn to use the tree diagram. So you start with this spinner here. So you start here, and you in effect are drawing a map of all the things that could happen. So when you spin this, you could get a purple or you could get a white. That's all you can get. Later on, I'm going to add different colors in here, and then the table diagram will definitely break down. But anyway, so you spinning this thing here, and then later, and then let's say you assume you get a purple one, and then you jump to this one here, spin this one, you could get a purple or a white. Okay, purple or a white. And now let's go back to the beginning. You spin this one, so you're here, spin this big one, you get a white one. Now you get a white one, now jump to this one here. So you spin it and you get a purple or a white. So basically this, in effect, is a map of all the things that can happen. But the probability the probabilities would be different. Okay, so, well, anyway, in the next video, I will give you some more examples, and then you just do it a few times, and then you understand it after that. Okay.